quick review on how to deal with algebra and exponents. So we learned that there were two different formats when it came to multiplying with exponents. The first method was if I had two separate bases, x to the a, and we are multiplying it times the same base with a different exponent. In this scenario, we are going to add our exponents. So whatever a plus b ends up being, our base will remain x, whatever it is, and we are going to add a plus b. The other format we had was x to the a, whatever it happens to be, and we are raising it to the power of b. In this situation, we are going to multiply our exponents. So x to the a times b. So we have to look at what our situation is and use the appropriate solving method. For instance, our first problem, we have x to the fourth times x squared. If I take a look at it, it looks similar to our first solving method. Same base, different exponents. So in this case, we're going to add. So x and then 4 plus 2 is going to give me 6. Number 2, same situation. We're multiplying the same base. Negative 3 to the second, negative 3 to the 11th, times negative 3. Because it's the same base, I'm going to add all our exponents. So 2 plus 11, and again, I don't see an exponent, so I can say that this is 1. So negative 3 is our base that we're working with, and then 2 plus 11 plus 1 is going to give me 14. Number 3 is a different situation. I have 2/3 w to the fifth, and I'm raising it to the second power. So if it's inside parentheses with an exponent outside, it looks like our second solving method. So whatever's inside our parentheses here gets raised to the second power. So our number, 2/3, I'm going to square. Gives me 0.4444, on and on forever. Again, to turn it back, our problem has a fraction, so we need to turn our answer into a fraction. So math to fraction, so we can hit number 1, gives me 4/9. So 4/9, w, and then I multiply 5 times 2, gives me 10. Number 5, from there we move on. I'll do number 6 really quickly because it's similar to number 5, number 8 here, number 7 as well. If I have two separate sets of parentheses here, each being raised to a separate power, I have to do each individual parenthesis first and then do another step if I have to. So 3x to the fifth cubed times 2x to the seventh squared. So in this case, I am raising 3x to the fifth to the third power, and I am raising 2x to the seventh to the second power here. So which format do we use? Well, it's set up like our second possible solving method, power to a power. So whatever's inside parentheses gets raised to the appropriate power. So 3 to the third here gives me 27. X to the fifth being raised to the third, power to power, I multiply. X is our base. 5 times 3 gives me 15. And then I have to do the same thing with our 2x to the seventh. I am squaring it. So 2 squared is going to give me 4. And then x to the seventh to the second power, 7 times 2, x to the 14th. So notice here that I still have two sets of parentheses. No space in between means we are going to be multiplying these things. So this means I will multiply number times number, letter times letter. So separate base now means we are going to use our first solving method. First and foremost, I have to do 27 times 4, number times number. So we have 108. And then x to the 15th times x to the 14th. In this case, because my bases are separate, I will add the exponents. So x is our variable here, and then I will add 15 plus 14, and I get 29. So the answer in this case is going to be 108x to the 29 after using the solving method of raising a power to a power to get to our first step. And then from our middle step here down, I'll use the first solving method where I have separate bases. Again, number times number, letter times letter, using the appropriate method, whether we add our exponents or multiply the exponents if we raise a power to a power.